Okay, so on Friday we did an activity where we collected data using the CBR, the computer-based ranger, and it was a motion detector. And so for those of you that were not able to be here, what happened was we had a person that was standing in front of a CBR, a little handheld motion detector, and what they did is they walked back and forth, like let's say here is the CBR, the person with the CBR, and then here is a line, and it was marked with feet, little tick marks that represented feet. And so a person would stand here, let's say that here is a person, and that person would walk away from the motion detector and to the motion detector based on the graph. And so as we're looking at this first graph, we're going to make this x-axis represents the time in seconds. The time in seconds. And so each of those little tick marks represented two seconds. And so let's say for this one, we are needing to figure out, first of all, where we're starting. Now remember that this is feet, so this might have been, they were pretty close together. This might have been that the person was starting at the 2 feet mark. This was feet. And then the person had to move away from the CBR because if you'll notice the distance is increasing between the person is here, and the CBR, which is here. And so as the person moved away, the distance got bigger. And so what we wrote in our description here was that the person started at 2 feet away from the CBR and walked quickly away. Okay? Then, for this one, again, this is time in seconds, and this is the number of feet. And if you'll notice, remember, this is the CBR right here. This is the person holding the CBR. So in this one, the person would have to be pretty far away from the CBR. So we are starting far away from the CBR. And then the person would have to be coming towards the CPR pretty quickly because the distance is changing very quickly. And so the person would walk to the CBR quickly. You'll notice that it's quickly because the distance is changing rapidly as the seconds aren't changing very much. So we're going faster because the distance is changing faster than the time is. On number 3, you'll notice that the person here's the person, and here is the CBR. The person is standing still for a while because the distance is not changing at all. So we're going to say stand still. At this mark, the person would be increasing their distance between them and the CBR, so that means that we would walk away from the CBR quickly. And then we're going to change directions and come back towards the CBR a little less quick. And we'll just say at a moderate pace. Now if you look at number 4, notice how this line goes. We start, the person is pretty much standing still at the beginning, but look at what happens here. Yes, that we would increase our speed, but what's happening right here? Remember, this is the time in seconds. We had quite a few people try to make this graph today, and it was quite amusing to watch them try to turn around in circles and go forwards and backwards really fast trying to make this. But what we found out was that you can't go backwards in time. Notice how this one is going backwards, and you can't go backwards in time to create this graph. So this one was an impossible graph for us to create by someone walking because you can't go back in time. So we answered some questions along the left-hand side that we have. We're going to number these 1, 2, 3, 4, 5, and 6. And then we're going to answer the questions inside this blank space here, somewhere where you can find a spot. So it says, how do you know where to start walking? Remember, you're going to look at the y-axis to know where to start. So we're going to write number 1, look at the y-axis. Let's look at number 2. How do you know how long to walk? Well, remember, the time in seconds is on the x-axis. So you know, like for the number 3, the person may have walked or may have stood still for maybe 3 seconds, and then they walked quickly backwards for maybe 2 seconds, and then for the rest of the time, they walked forward a little less fast. So this one, for the how long, we're going to look at the x-axis. For the third question, how do you know when to walk to or away from the motion detector? Well, we remember that the ones that were going up, that was away, and the ones that were going down, that one is to. So we're going to write to is down, and away is up. So to is down, and away is up. So let's look at number 4. Number 4, how did you know when to walk slowly? We really didn't see it as much on these 4 graphs, but we did whenever we were trying to match the graph on the screen. And what happens is when we have a flatter line, we are going slower, like this. The distance isn't changing as much as the time is. Now, opposite of that, how do we know when to walk quickly? We would know when to walk quickly when the line was steeper. And you can actually see it here on number 2. This line is very steep, and so we walked quickly. We can make it going to the CBR or away from the CBR, and we know that our line is steeper. And then number 6 was, how do you know when to stand still? Remember, whenever the distance is not changing at all, it is a horizontal line, which means that you are standing still. Horizontal line. Now, some of the classes we did the back 3 questions. Some of the classes we did not. And so we will finish up and make sure that everybody has these questions answered, but let's just take a look at one of them. It says a bus route stopping to pick up passengers. Now, we're talking about speed along the y-axis. And so what we have to do is decide which graph says that the speed of the bus is going to allow stopping and allow picking up of passengers. And if you look at letter A, this one cannot be the answer because it never stops. Notice how it speeds up and then it slows down. Remember, we're talking about speed here. It speeds up, slows down, but it never stops. Stopping would be down here on the x-axis. So this one cannot be it. Look at letter D. This one is just continuously increasing the speed, and it's never stopping in order to pick up a passenger. So we're left with these 2. Now, remember that a bus is going to start, and they're going to go for a little bit, and then they're going to stop, pick up a couple of passengers, go ahead and start again. And so, as you're looking at these, the difference is that this one on letter C allows time for the picking up of passengers. So C has to be this one. And we will make sure that everybody has the other 2 filled out, and then we're also going to come up with a summary on Tuesday. Have a great weekend, and we'll see you Tuesday.